My name is Bhekuzulu Khumalo. I'm going to give you a presentation. The title is A Treatise on Information, Knowledge, Economics, and Technology. Everything we have in this world is information. This hat is information, I'm information, you are information, this table is information. Everything in the universe is information. That is the latest definitions we're getting from quantum physics. All information comes in packages. So as I've illustrated here, we have a package of information, and that information, I've called it I. And the size of an information package depends on the information. It can be one thing or it can be everything. You can be an isolated package of information, and the whole universe is a package of information, is one package of information. So here I can show you the size of information package to deal with what in our reality. We have an elementary particle, is the smallest particle package of information we can get known to us right now, and everything is the largest information package we can get. Now all information is discrete. It comes in discrete things. It cannot be divided. So we have, I'm showing here, we have a packet of information here, and I've put numbers in there, but you can think of them as particles, you can think of them as human beings. I put numbers, there's 1 plus 1, 2 plus 1. It can, but the answer, it can be this or that. It can't be both of them. See, and now we have, information is independent. This package of information is not the same as that. Even though we have 1 plus 1, then 2 plus 1 like here, but they're not the same because that's two packages of information, and this is one package of information. And now if there was no independence of information, it means we could not have this package of information. Because information is independent, that's what allows us to learn. Because that means we can learn in different ways. We all don't have to learn in the same manner. And now the most important thing is we can isolate information. That's why we can learn. I can take this hat, I can isolate it all the way down to its atomic constituencies. That's what we call isolation of information, like there. Even though that's not the same, but I can first teach a child 1 plus 1 equals 2, and then I can teach a child 2 plus 1 equals 3, because I can isolate information. And you can take this, it's a hydrogen package. Let's say it's water, that would be hydrogen, that would be oxygen. I can split it up. That's where I can learn. Otherwise, if I couldn't isolate information, I'd have to learn everything. I'd have to know everything or nothing. Now all information becomes complex from the stage after it is an elementary particle. And all systems are of information, and all systems are information comprised of energy. The smallest system is an elementary particle. Now, this is just to make us understand. I know we're economists here, we're educators, but I'm going to give you, this is a package of information. It has energy that holds it together, and it has free energy that allows us to do. If I'm a human being, I have energy that holds me together, then the other information allows me to do stuff. The free energy allows me to do stuff. It allows me to come to work, it allows me to go home, it allows me to love. And now we have free energy, and that's binding energy. Now we have a two-system solution of information. Remember, everything is information. I have this system here, and together, me and you, we have formed a system together. You don't have to be here, but your free energy has allowed you to come here. You know, you could be in a different country, you could be in a different world, and all the choices you've made in life is because of the free energy you have. So that is the solution to a two-system energy, but you can take it as particles, elementary particles, or you can take it as human beings, or you can take it as stars. And that's the equation. So what we have, the two-system solution, we have that the first thing is you can add up all the energy F, you subtract the bonding energy, and that's what gives you your energy to act. And all energy is equal to the free energy, the energy that allows me to act, that allows me to walk, plus the energy that I am made up of. Even all systems are like that, economic systems, So that is the final solution to a free energy to two systems. And that is the final solution for free energy. Now, everything in the universe that exists depends on that relationship. That is complexity. When they talk about economics and complexity in economics, in society, in the universe, that is complexity. That is the equation for complexity. And you are the first human beings to publicly know this equation. And that's free energy for you. Sorry, that's it. It's squared. Now, this is a complete system of energy. Now, this can be two economic systems that make a trade deal. There will be something, because when you make a deal, when you make a trade deal, you have a bonding system between you. You have to follow the laws of that bonding system. You have to follow the international laws, like you say, this is trade. I can sell these cars for this price. And it's the same as particles. It's the same as universes. It's the same as galaxies. But here we can take it as an economic system for our understanding. But everything behaves the same. Now, complexity affects all systems. It affects particles, atoms, molecules, economics, corporations. When two corporations come together, that's why you get a lot of layoffs in corporations. Because that bonding energy has to come together, and then there's a price that must be paid. So people are laid off. All institutions, whether it's a university, all governments, all cells, all chemical relationships, and it increases specializations. As a system becomes more complex, the free energy will come down. That's because we are becoming more specialized. As a child, you had lots of free energy. You could want to be anything, but now you are teachers, we're professors. Because that free energy has gone, we're specialized. And when you make trade deals, the free energy disappears. Countries become specialized. That's why they talk of stuff like comparative advantages, economic advantages, and competitive advantages, because you become specialized as the system becomes more complex. Everything becomes more specialized. Atoms, you get particles, you have protons, neutrons, but then it becomes more specialized as there's complexity. You start getting gold, you start getting hydrogen. These are complex things, and they're specialized. Even though it's the same atom in gold as it is in hydrogen, it's the same electron, but it's specialized because of the system it's in. It has become more complex. That is complexity. And now, for our reasoning, because I'm going to make things, let's talk in an economic sense. Let's talk that we have a package X. A package X is knowledge concerning the laws of existence, what we know. And then package U is a package that is, we create goods and commodities. See, I have this hat. It's made from leather. I know that with leather I can create this, and it's waterproof, and I can make a hat, and I can put it on my head. But before I can make this hat, I must know the laws of the universe. And then with that, I can make a corresponding good. This is a glass. This glass comes from sand. I must know that before I can make this glass, I must first understand that when I melt sand, I can make a glass. So before anything becomes a commodity, I must know its scientific principles. And even a caveman had to know the scientific principles of what to eat. This food will poison me. This food will not poison me. So knowledge, even though people talk of a knowledge economy as something that's starting just now, that is wrong. Knowledge has always been the basis of a human survival. Even animals must survive with knowledge. And here I'm showing you, as x is big, xi plus 1 is bigger than xi. So as our knowledge increases, our goods and services increases, our commodities increases. Ui plus 1 is, so this is bigger than u2, and x3 is bigger than x2. So as we get more and more knowledge, we get more and more variety of goods and services, because goods and services only are derived from the laws of existence that we know. And now, the isolation of information. So before you can have anything, you must have a theoretical extraction. the caveman had to know which stick he's going to use, you know, to fight. He has to know how is he going to fight a wild animal. Is he going to use a stick or throw a water? He's going to use a stick because the stick is rigid. So that's what he's going to use to fight an animal. And then from that, we're going to get verification. And from the verification, we're going to get use knowledge. And that use knowledge is what we call commodities. And let me read this for you. The wonders of the age are marvelous. Some people argue that our products resulting from quantum mechanics are around 45% of global GDP today. But we know all information can be isolated. When we can bottle electricity, we would have gone a long way. It is not yet even in the imagination, yet a small, loud and dramatic people talk of some sort of technological singularity, that we are reaching the end of human progress, but we can't even bottle electricity. Because if everything can be isolated, that means everything can become a commodity. When I'm talking about bottling electricity, I'm not talking about the electricity running through a wire or in a battery. I'm talking about bottling the force of electricity itself, bottling the force of light itself, so that it doesn't have to come out from any instrument. And when we understand, now I'm a knowledge economist, but when we understand information and we understand what we can do with it and understand that all information is the same and that we are all, because what is a scientist? Somebody who extracts information. And this is just to play with you and show you something. That is the beginnings of what we call a quantum phone. Phones that using quantum technology instead of, so we have that. This is instantaneous talk. You can talk to someone instantaneously with somebody on Jupiter or here or even in a galaxy 2 billion light years away because of what is called entanglement. But this is understanding, that's because we understand what information is. Now that is the last of my slides, but I'd like you to know, what is a scientist? A scientist is somebody who extracts information. So we are all scientists here. Whether you're a social scientist, you're doing exactly the same thing as a physicist. Because you're extracting information and you're beginning to understand the universe. Thank you very much, brothers and sisters. I love you all.
Thank you. I appreciate your passion for your topic and your discipline.
Thank you. But read on it, the paper. I've given you the paper so that you understand it better. Because with slides, you know, it's never as deep as I'd like it to be. But you'll understand it better when you read the paper.
Any questions, guys?
We're done. Thanks for the love.
Thank you.